So this is number 51. What is the specific heat of liquid water? The specific heat capacity of liquid water is 4.184 joules per gram degree Celsius. It's probably a good number to memorize because that's the specific heat capacity, or C capacity, or our book sometimes uses an S, or sometimes you'll just see a small letter C as well. That's the specific heat capacity of liquid water. Letter B, what is the molar heat capacity of liquid water? Well, now we need to just change from grams to moles, and so there are 4.184 joules per gram degree Celsius. Continue this line right here and put grams in a position where it's going to cancel, and put moles as your new set of units, and add up H2O on the periodic table. Well, two H's and an O add up to 18 grams in 1 mole. Now my grams cancel with my grams, and I'm now given joules per mole Celsius. And so when you multiply those together, you get 75.4 joules per mole degree Celsius, and this would be known as the molar heat capacity of the liquid water. This, called the specific heat capacity, is specific to grams. Letter C, what is the heat capacity of 185 grams of liquid water? So now we know that this is the heat capacity for 1 gram of liquid water, because if you wrote a fraction here, you could actually put a 1 down here, so it's 4.184 joules per 1 gram. Well, if we had 185 grams, we would multiply it by 4.184 joules per 1 gram degree Celsius. So notice my grams will cancel with my grams, and this will tell me my joules per degree Celsius that I have for 185 grams. Multiplying those two together, I get 774 joules per degree Celsius. And then lastly, letter D, how many kilojoules of heat are needed to raise the temperature of 10 kilograms of liquid water from 24 to 46. So Q, or heat, at constant pressure is delta H is equal to M times specific heat capacity times change in T, so MC delta T, and it's asking for my heat, or my Q, right here. Now you have to watch out for your units on this, because obviously the specific heat capacity is in joules per gram degree Celsius, and they're giving us it in kilojoules, or they want the answer in kilojoules. They also give us kilograms for liquid water, and this is in grams. So the first thing to do is convert your 10 kilograms to grams, and that's just 3 to the right. 1, 2, 3, so that would be 10,000 grams of liquid water. So that'd go in for our mass. Our specific heat capacity, of course, is 4.184 joules per gram degree Celsius. And then our change in temperature is temperature final minus temperature initial. So 46.2 minus 24.6. And now we can put those together in this MC delta T equation. Doing the math together for those ends up with 904 000 joules, so 904,000 joules. 3 to the left would put us at 904 kilojoules for the amount of energy.